Hello, welcome to my channel Devops with Prasanna, and this is day three where we are going to talk about load balancers. So once I prepared the material, I felt very confident that this is going to be like very interesting session, and we are going to have a very exciting demo. So let's get started. Yeah, this is what we are going to set in today's session. This is a whole setup. We are going to have EC2 instance. We are going to have load balancers. We are going to route traffic to the EC2 instance. But before like getting into all these details, there are some prerequisites. So which we'll understand and then we'll get into the demo part. So the first one, like why we should use load balancer? That is a most fundamental question. Yeah. So why to use LB? So if you want to know why to use LB, we should first see like what will happen if you don't have LB. LB means load balancer. Let's say you have users and you have your application deployed within a single EC2 instance, like how we did in the like two sessions before. This is your app and this is your user. Let's say like you are using an instance called T2 micro, which is very small, and this is what we are using. One virtual CPU and 1 GB of memory. You are doing some kind of capacity estimation and you could able to find that your T2 micro instance can handle only up to 15 users. But your application became very popular and there are a lot of users. And now the total number of users in your application is 30. So what will happen in this case? Some requests will fail, the system will crash, all bad things will happen, right? Yeah, which we don't want to do. So the catch here is like how to rectify this issue. Either like instead of T2 micro, you can go to a bigger machine, like something which we saw in the previous lectures. M5 large, M5 2X large, machines like that. That type of scaling is called as vertical scaling, which means you are making the EC2 instance or the machine to a bigger size machine. So instead of this smaller machine, you're going to have a bigger machine like this. And this could probably handle up to, let's say, like 150 users. But what will happen if you have 500 users, 1000 users, 2000 users? This vertical scaling approach will not work in that case because there is a limit to what is the maximum size of EC2 instance you can go. So that is a catch here. Then what is the solution? Yeah. So instead of vertical scaling, there is one more alternate approach. It's called as horizontal scaling. So this horizontal scaling means instead of having one EC2 instance, we are going to have multiple EC2 instances. What I'll do is, yeah, maybe I'll write it in this. So we have one bigger machine here, and similarly, what we'll have is we'll have one more machine here, which is also a bigger machine, which will have our application deployed. And these both machines combined together will handle the user request. And let's say if your user number of users grow, you'll add one more machine to it. If you have further more users, you will add one more machine. So you got the concept, right? Like instead of making a bigger size machine, you are increasing the number of machines. So that is called as horizontal scaling. And this is the scalability factor. So the advantage here is, for example, your user count is getting reduced, which means instead of having four machines, you can have two machines now. So this kind of scaling in and scaling out is possible with the load balancer. So that is the key. And let's say like you have, let's take an example where you have two machines. There is a load balancer sitting in between. Okay. So there are two EC2 instances and one EC2 instance is crashing for some reason. Okay. So if this is getting crashed, then load balancer will not route traffic to this instance. Instead, it will route traffic to EC2 instance one. All the requests will go here, which means your end user will not be affected because one machine got crashed. Like because I said it's just two machines, the scenario could be like very simple. But take a case where you have 100 machines. Okay, so you have 100 machines, and out of this 100 machines, 78th machine is failing. Okay, like from the Devops or infrastructure engineer perspective, that 78th mission is failing, but the end user will not know anything because for them they are accessing the load balancer and they are getting the response from any one of these missions, any one of this remaining 99 missions. So that is the advantage of load balancer. It will make your application highly available. The next one is the fault tolerance. We discussed about this fault tolerance in the previous session when we are talking about a VPC subnet availability zone. So the fault tolerance or disaster recovery is, for example, there is some issue with the AWS itself and one of the AZ is going down. So in that case, if you design your infrastructure properly, you would have set up something like this. This will be instance one will be in AZ1 and instance two will be in AZ2. To give a concrete example, your instance one could be in AP South 1A, which means Mumbai North region. Yeah, just give me that. Just saying that like Mumbai North availability zone, and your one more mission will be in Mumbai South availability zone. So even if one AZ goes down, your application will not be affected because for the same reason. So this AZ itself gone down, but still your traffic will be routed to the other AZ, and your users will have no issues at all. So that is a fault tolerant. So this is how you should design your infrastructure. It should be like highly available, fault tolerant, and it should be scalable. There are like I want to talk about the point number 5, fixed connection endpoint. For example, if you directly talk to your EC instance like this, which means yesterday we saw this one, right? Like we can have a public IP address, but if you stop your mission and start your mission again, the IP address will change. Let's say like you have some mechanism so that the public IP address will not change. The mechanism is like elastic IP. So you're setting elastic IP and making a fixed public IP address. But still you are hard coding the IP address in the client side, which is not a good thing to do. Instead, if you have a load balancer, then whatever instance which you change here, it doesn't matter. Your client will always talk to your load balancer and load balancer will know how to route the traffic to the corresponding EC2 instance, which means there is a loose coupling between the IP address and how the users talk to that IP address. So this is the fixed connection endpoint stuff. And the other one which I want to talk about is SSL termination and connection draining. So in this today's session, we are not going to talk about SSL certificates. I'm planning to do this for tomorrow or day after tomorrow. But just to give you understanding, if you have SSL certificates, HTTPS traffic, then what you can do is your users will be talking to your load balancers using HTTPS. But load balancer will talk to your EC2 instance using HTTP, which means load balancer will take care of making sure that the traffic is decrypted and the decrypted traffic is going to EC2 instance. Your application need not worry about any of this encryption decryption stuff which will happen at the TLS, like the TCP layer. So all this can be handled at the load balancer level itself. And the good part about AWS is they have all the managed services for us. For example, to manage the certificates, they have ACM, which is AWS Certificate Manager. And that is like a very good integration between those services. So it is very easy for us to set up the SSL termination at the load balancer level itself. So that is the concept of SSL termination. Like who will terminate the SSL and who will convert that traffic into a normal plain text traffic. So in this case, load balancer can do that SSL termination for us. Okay, so cool. This is why you should use load balancer. So that is a objective. Cool. Now, before going into the concepts of the load balancer in AWS, we want to know about, I thought of discussing one more theoretical aspect. That is called as OSI model. So if you are a computer science student, definitely you would have learned this in the networking subject. The 7 layers of OSI. So this OSI, the 7 layers, it's application, presentation. You know what? How I remember this in the college days is a princess saw the Negro during party. So I just memorize this expansion, and that's what I'll use it to mug up the things and write it in the exam. If you're doing that, please stop doing that because that's of no use for us. Instead, like what I'll do is I'll try to explain this theory in a slightly practical way, but I'll not go deep into it because that is irrelevant to what we are going to discuss. But I'll see if I can make it somewhat relevant to how the load balancers are being set up using this OSI model. Okay. So the 7 layers of OSI, like for example, if we have a client machine, if we have a server, for example, like the client machine will have all these 7 layers. It will send the traffic to target machine. It will decode all the 7 layers and give the response to server. So that's what it's going to happen. And between in these wires, plain bits, ones and zeros are going to get transmitted. Okay, this 7 layers. So the first layer is application layer. Okay, this is a layer 7, which is the topmost layer. What is meant by topmost layer is your user is sitting here. Okay, your user will directly talk to application layer, which means it's more user friendly because this is the layer in which the end user is going to get the content delivered, and it will deal with HTTP protocol. It knows how to read the HTTP messages, HTTP host, path, header, query params, and all those stuff. This is, as I mentioned, it's mostly catered towards the application needs. Then comes a presentation layer, which means how your data is going to be presented. Like what is the compression format we are going to use, whether it's a JPEG, whether it's a zip format, what it is going to be. The next layer is session layer, where we are going to handle the session creation, termination, whether it's a valid session or not. All those things are handled in the session layer. The next layer is the transport layer, which is important thing for us. It will take care of managing the delivery of the packets. For example, like there are two types. One is TCP, the other one is UDP. So TCP is a reliable delivery, meaning like you'll get acknowledgement. You'll make sure like the other party is also getting the data through a connection being established between both client and server. So that is the TCP protocol for the communication. And this is mostly used in all the places compared to UDP, where it is very fast. It's used for broadcasting the messages, and there is no connection, and there is no acknowledgement also. So that's why like it's very fast, and it's TCP is a little bit slow. And this is also an important thing for us because from the AWS load balancer perspective, we can create load balancers at two levels. Either we can create it at application layer or we can create it at the transport layer. So what is the difference? Like in the application layer, it's called as ALB. Network transport layer, it's called as NLB. Okay. Yeah, maybe like we'll see the rest of the layers and then we'll come to what is ALB, what is NLB, what is the difference between those two things. Yeah, network layer, it will determine which route to use based on the shortest path or things like that, and then to route the traffic to that router. And data link will convert the data into frames, and then physical layer will convert the frames into the actual data which is needed by those end wires. So it's going to be the bits, ones and zeros. Now, yeah, we'll come to this ALB and NLB, which are the two interesting things for us. ALB versus NLB. Okay. So there are three types of load balancers which you can create in AWS. ALB, NLB, and one more thing is GWLB, which which is which is catered for a very specific need. And what we'll do is, if we have some time, we'll discuss about GWLB at the last. First one is application load balancer. As we mentioned, this is going to be the top layer. This means it knows what are the HTTP protocol, HTTP verbs being used and things like that. For example, verbs in the sense you would have known about a get, post, put, delete, and HTTP verbs like that. And the HTTP will be having its path, its host headers, and things like that. So you can when you are creating a load balancer, you can use all these parameters to route the traffic to a proper EC2 instance. So that is the idea. To give an example, like there is a testing method called as canary testing. What this means is, for example, you have end users, okay? You have your application. Let's say you want to deploy one more next version of your application. So let's say like this is V51. You want to deploy V52 version. Before doing a deployment, you can do a canary testing, which means you can say like only 10% of users can access this V2, whereas 90% of the users should access the older version. And what you can get is out of this 10%, you can monitor and you can get the feedback to see how the user behavior is for the V52 version. If the user behavior is really good, then you can route 100% of the traffic to this new V2 and you can destroy the V1 version, 51 version. So this is called as canary testing. So this kind of testing is possible with application load balancers because in the headers, you will be passing some parameters. Based on that parameter, you will choose which, maybe like for example, we'll choose which EC2 instance it should point to. So that is advantage with ALB. You will be using ALB where performance is not critical. Performance in the sense, if it's like for example, stock broker site or a gaming application where performance is of utmost importance. In those cases, it's not advisable to use ALB. But in all other cases, you should first start with ALB. And if you have like a very specific need, like this gaming application, then you can go to NLB. Else you always stick with ALB. That is a objective. And also like for NLB, it's not available in free tier. So that is something which you should keep in mind. Only ALB is available in free tier. And ALB suits well for the microservices based application. The reason why we say it's suitable is first point, like what is meant by microservices? Let's say you have one big application. Okay, this is a very big e-commerce site. The trend is this is called as monolith. Okay, so the deployment is very difficult. For example, there is like one application, so everyone will be working on this application, which means like hundreds of developers will be there if it's a big site. And doing a deployment will also take a lot of time because it has to do a build, it has to do all other process. But instead, if you break the site into smaller applications, for example, order service, I'm just coming up with the names, payment service and things like that. So for example, in like if there are 100 developers working here in the payment service, maybe like there'll be some 15 developers. And the amount of change which is going in, which is also will be very minimal. And the size of this payment service will also be smaller compared to the monolith application, which is a very big application. So this is called as microservice, breaking down the bigger application into a smaller chunks, but the functionality should remain the same. So again, like I'm explaining microservices in a layman term, so like you can understand the basics of it. This is not to go in depth into microservices and things like that. But the catch here is, if you have this ALB will suit well for this microservice based application. The reason is based on the host header, you can route the traffic to different services. So you can route traffic to order system or payment system based on the HTTP verbs itself, or sorry, HTTP host header itself. So this is possible in case of ALBs. But in case of NLB, what might happen is for each and every system like this, order system, payment system, you have to create a separate network load balancer, which will be like, which is not cost efficient because you will incur charges for more than one load balancer. Whereas in case of ALB, one ALB is sufficient to handle all the services. Yeah, so I think like this is the basic difference between ALB and LB. But the way you create both the load balancers is more or less it's same. There is like no big difference except the way you define the rules and the health checks. Okay, so I think like we covered most of the part. Before going into the demo, I just want to explain these concepts also. So when we create the actual load balancer, you know like what we are creating. Else it will be just a click ops. So there is a terminology called click ops, which means you are going to console and you are just clicking the buttons without understanding the things. And it is not recommended uh, because the it after the cloud computing came into picture, it's very simple to create like services like the load balancer, VPC, everything is very simple to create. The catch is you should understand what it is, understand what is the best practice, and then create the things. That is a objective. So don't do ClickOps, do DevOps. Yeah. Coming to this load balancer. Yeah, so it like we talked here about this load balancer and EC2 instance. It is not that straightforward in AWS. Like there are few more components as well. For example, your EC2 instance is sitting here, and if you want to like first thing is you should group this EC2 instance using a target group. So there's a component called target group, which will group the similar instances together, and it will do the health check also, which means this target group will ensure this EC2 instance has the application or not, and whether it's serving the proper response code or not. So all those health checks are done by this target groups, and you can have multiple target groups, and this target group can be attached to a load balancer, and that is the concept called as listeners here. So based on this listeners, you will know like which target group to route to. Like this is like basically like there are some more rules as well. So based on these rules, you can route the traffic to the target group, and from target group it will pick one of the EC2 instance. So that's how things are going to work. And yeah, I think I forgot to mention one more concept, which is how the traffic will be routed to the EC2 instance. There are various methods which are being used, like round robin fashion, where the request is sent to different nodes for each and every time. For example, the first request will come here, the second request will come here, third request will go here, fourth will come here. So this is called as round robin, or it could be based on the load also. For example, if this EC2 instance is having huge load, then the request will be sent to this EC2 instance. So that based on load also, the load balancer can route the traffic. Or there is a concept called as sticky sessions. Sticky sessions in the sense, for example, when a request is routed to this EC2 instance, from the same user, if one more request comes, it should go to the same EC2 instance. So that is called as stickiness. And if it's coming from a different user, it can go to EC2 instance 1 or EC2 instance 2. But once a request is served by one instance, all the other requests from that same user should go to the same EC2 instance. This is mainly used for maintaining the sessions and things like that. Yeah. So these are the theoretical concepts which I want to cover. Now we'll get to go to the hands-on demo, and then we'll come back here and check the understanding. Okay. Okay. Cool. So this is the EC2. Okay, maybe like we can start from AWS console. So go to AWS console, search for EC2, and then come here. This time we are going to create EC2 instance in a slightly different way. So launch the instance and go to this number of instance and select the number of instances too. Okay, and then give the name as day 3 load balancers. Okay, let it be Amazon Linux itself. We don't have to change all these parameters. Let it be T2 micro, and then use your key pair which you created in the first session. Yeah, and hopefully now you should understand this VPC and subnet, because in yesterday's session we talked about this VPC and subnet. If you haven't watched that session yet, I'll link it here. You can please go and watch the session. And what we'll do is we can create a default, like it can create the security group, but we'll just allow the HTTP traffic. In this session, we'll go into security group and we'll edit the things also, so you can understand it in a better way. And we don't have to modify any of these things. This is good. But there is one more thing which I want you to do, which is go to this advanced details and then go to a section called user data. So basically, this user data is nothing but a script which you can run at the start of the EC2 instance. So the advantage here is we know what we want to do. Like we want to serve some kind of static content using Apache in both the machines. Okay, that's what we want to do. So we can write a script and we can execute the script at the start of instance itself. So we don't have to SSH into the machine and do things like that. And to get the script, go to Learn AWS in 30 days, go to day one. This is the same script which we are going to use. So I'll copy this one and then I'll copy this also. Okay. So just to quickly summarize what it's doing, maybe like you don't have to do sudo su because this user data will always be run as a sudo user. So at the start of this mission, it will do yum update -y is for do the update without waiting for the user confirmation. And then it'll install the HTTPD, which is Apache server. It'll enable the HTTPD and then it'll start the server. It'll just check the thing, which we don't want to do because there is no one to check. Go to this folder and then just copy this message into index.html. But the beauty here is we are using hostname -i. This will give the private IP address, which we have seen before. This private IP address will be different for different machines because we are going to create two machines. This two machine will have different text. That's what we are going to see. And we'll remove this last curl also. So this is good. Just go and launch the instance. Okay, so if I go here, I can see there are two missions. Just two for us for understanding. I'll say like one. This is going to be two. Okay, so these are two missions. We'll just wait for the mission to be in running state. And hopefully should have understand like why it got the public IP address. Because when we are creating the EC2 instance, there was one parameter which said enable the IP address. So that's why like we got the public IP address also. And both the machines belong to public subnet, and it has enabled the public IP address. Cool. So now we have two machines. It is in the initialization phase, but yeah, we'll check this one. So I'll copy the IP address here. We'll go to new tab and say HTTP. We'll type the IP address. We'll wait for like few seconds to make sure like it can serve the traffic for us. Yeah, so cool. Okay, so you can see it is giving the private IP address, which is 8.189. So if I go to the private IP address, it's 8.189. And if I go to the next one, cool. So this is giving 172.31.12.160. Cool, 160. So this is great. So we created two machines using the user data. So that is also like one key point which you should note. Then the next one which we want to create is target groups. Okay, maybe like what we'll do is we'll go to load balancer, we'll create a load balancer, and from there we'll create the target group. Yeah. So in this load balancer, this is the three type of load balancer which we discussed: ALB, NLB, and a very niche case where it's a gateway load balancer. I'll see if we have some time to explain this also. But this application load balancer, it will deal with HTTP, HTTPS, and then it's for the application layer, and network is for very high performance, and then it'll operate the network level. So it understands the IP address and port. That is the only thing it can understand. It can't understand the header, host, path, query parameters, and things like that. In this demo, we'll create the application load balancer. ALB. I'm going to set it as internet facing. It's IPv4, and the VPC is a default VPC which we have. And I'm going to create it in all the subnets. So it can use all the subnets to route the traffic. And instead of having a default security group, we'll create a new security group. For example, it is my security group, learn AWS, learn AWS listing. Okay, and then I'm going to add some inbound rules. So inbound rules is nothing but whenever we create the EC2 instance, we just gave a tick mark, allow HTTP traffic. This is what the rule it's going to add. So we are going to manually add this rule here. Allow HTTP traffic from anywhere, IPv4. So the CADR notation is 0.0.0.0. So this is what it has to do. And all the things looks good. So create security group. So we have created a security group for this load balancer. So if I refresh this, and if I come here, my learn is. So this is a security group which we want to attach. And then we want to select a target group also. But we don't have a target group yet. So I'll create a target group. And this target group, it should be based on the instances. So as we discussed before, this target group can be for IP address or Lambda function or application load balancer. So these are like slightly advanced scenarios. But in our case, we want to use the instance, which means this target group is going to contain set of EC2 instance, and it has to route traffic to those instances. I'll say learn AWS target group. Okay. Protocol is HTTP 80, IPv4, HTTP 1, and then health check. So this is what we discussed again. It will see if the slash endpoint is available or not in the port 80. If it gave the response code as 200, it is good. But I'll show the advanced check also. For example, the healthy threshold, the number of consecutive health checks, it should be, it is by default it's 5, but I'll make it as 2, which means if the 2 health check pass, then this instance will be in a healthy state. That's the idea. For example, for 2 consecutive checks, if it fails, then it will mark the instances unhealthy. And the timeout is 5 seconds. Interval between each and every check is, let's say, like 5 seconds. It's a minimum thing. So it will check for every 5 seconds. And the response code is 200. So our slash endpoint should give the response code as 200. That is a response status code. So all these things looks good. I'll create, let's solve the interval. Okay. Let's see this thing. Health check timeout must be smaller than the interval. So healthy threshold is 2, interval is 5. Okay. Between 2 and 20. Okay, cool. So like we should select the targets, which means what are the instances which we are going to include in the target group. So we are going to include these 2 instances, include as pending, and the port it's going to access is 80. So all these things looks good, and then I'll create the target group. Okay, so this looks good, but the target group is not it's not in a it's unused state. And the load balancer is none. So there is no load balancer attached to this. Now we'll go back to the load balancer. We'll refresh this, and then we'll select AWS TG. So this looks good. We don't have to set up WAF, global accelerator, and all those things. Create load balancer. So we created a load balancer, and this load balancer is forwarding to target group TG1. So like coming back to this diagram, what we did is we created this target group. We created the EC2 instances, 2 EC2 instances. We created target group. we create a load balancer. So we are almost done with this side of things. We are almost done with this portion. There is one more portion left, which is bottom one, which we'll see it in a few minutes. Cool. So this is fine. There is like one best practice which I want to talk. So if you remember, like once we create the EC2 instance, in the security group of this EC2 instance, we are allowing the HTTP traffic from anywhere, which means we can access this EC2 instance directly, or we can access the EC2 instance using this load balancer. So there are two paths to access this EC2 instance, but this is not a good practice. So we should always allow traffic only from the load balancer, and this EC2 instance should allow traffic only from this load balancer only. It should not allow traffic from the external world. Maybe like we'll just make this change also before this load balancer is provisioned. So yeah, it's still in provisioning state. So what I'll do is I'll go to dashboard, running instance. I'll go to the security group. So this is the security group. You can see like there are two rules here. One is SSH, the other one is allow HTTP traffic. So what I'm going to do is I'll edit this one. I'll delete this rule. And then I'll create a new rule which will say allow HTTP only from this security group which I have. This is my SG learn AWS. So I want to allow HTTP traffic only from this one and not from the outside world. So that is the catch here. So I have updated this, and this same security group is used for in both the instances. So what will happen now is if I go here, if I go to details, if I copy the public IP, http// this will not give back the result because it is not allowed. The outside world is not allowed to access the 80 port. We'll copy this. HTTP. Yeah, so these two things will not be allowed. Cool. Now we'll go to this load balancer and see if it is successful. Yeah. So the load balancer got created successfully, which means the target group should also have the instances ready. So if we go to the target group, we can see there are two instances and both instances are healthy. So you can see the status of this target group here. Now what we'll do is we'll copy the DNS name of this load balancer. So this is load balancer ALB. This is a DNS name. Because if you remember, we selected the scheme as internet facing, which means we can access this load balancer from the outside world. So I'll paste this one. Cool. So we can see like we got the message from one of the machine. Okay, we don't know like which machine it is. But if I do a refresh again, you can see like the IP address is getting changed, which means it's going in the round robin fashion. The first machine is giving the response, and for the next refresh, the second machine is giving the response. So this is cool. Like we are using one connection endpoint, which is the load balancer URL, but we could be able to route traffic to two machines, which is the objective for us. Yeah. So this looks great, and we can't access a machine from the outside world. Only using the load balancer, we could be able to access a machine. Now we'll come to the next part, which is having the multiple target groups. So we'll just configure this part also. What we can do is we can go to this rules, and we can say these are the listener rules. So I'm going to say like add one more rule. And I'm going to have a condition here. So the condition is because it's an application load balancer, we could able to add a condition like path, or we could able to add a condition based on HTTP headers. I'm going to say special. Okay. So if the path is special, then what it has to do is then return a fixed response. Like if we have one more target group, we can redirect the request to the target group. But in this case, we want to return a fixed response. And this response code should be 200. And the body is hello learners. This is as request. Okay. And I'm setting the rule priority as 1, which means this is a high priority rule. If this rule is not matched, then only it will go to the other rules. So you can see this is high priority rule. If it matches, the response code is 200, body is this one. If it doesn't match, then it will forward the request to the target group and do the things. I'll go to next. I'll say create. So this rule got created, which is good. So in this case, if I go and refresh this page, I'll get this message. Whereas if I go to /special, okay, I think it's not provisioned. Yeah, great. So it will say, hello learners, this is a special request. And if I go to /, it will give me this response. And if I go to some other thing, it will not show any message because we haven't configured anything in the Apache server. Cool. So I think we came to the end of this demo. We could able to add a rule with special rule, and then it routed the traffic to this particular fixed response. Yeah, and this is load balancer. Hopefully, it made things very simple, and you could able to understand what this application load balancer is. Yeah, see you next time. Happy learning. Bye bye.